Shipping is on a journey of decarbonisation, driven by consumer pressure and regulations such as the IMO's Carbon Intensity Indicator and inclusion in the EU's Emissions Trading Scheme by 2024. This is driving the biggest change in marine fuel since the transition from coal to oil over 100 years ago. At VPS, we're helping our customers to navigate on this journey by working with them and organisations such as the Global Centre for Marine Decarbonisation on R&D and sea trials to evaluate alternative low-carbon fuels. We've identified critical parameters affecting fuel performance, and we've applied our experience and expertise to develop bespoke test methods enabling these parameters to be measured. We've been able to establish that biofuels are drop-in fuels and can be used in existing engines without the need for substantial modifications. But they are significantly less stable than conventional fuels, and they tend to vary in quality and performance between different batches and suppliers. The most common biofuel currently being evaluated across the shipping sector is FAME, fatty acid methyl ester, and whilst the quality of this fuel is very variable, we've perfected methods by which its characteristics can be accurately measured. Establishing the renewable content of marine fuel is a critical part of reducing greenhouse gas emissions, and we can actually determine this using bespoke test methods which will allow our customers to calculate their emissions as required by the EU Emissions Trading Scheme. FAME is much less stable than conventional marine fuel, and as it ages, it oxidizes. The unsaturated content of FAME causes this instability, which is compounded by exposure to light, temperature, and storage time. We can measure oxidation stability in our laboratories using the Ransomap method, which deliberately accelerates aging of the fuel, and we also measure the unsaturated content as iodine number. Fuel energy content is important as it affects engine power output. The current calculation method used for conventional fuels can't be applied to biofuels due to the oxygen content, but we are able to measure the energy content of biofuels using a well-established method of calorimetry. FAME has poor cold flow properties due to the nature of the fuel, and so cloud point, cold filter plug-in point, and pour point need to be monitored. For blends with dark oils, an indication of wax formation is established using a wax appearance temperature test. VPS applies gas chromatography to measure the quality of FAME used in biofuel, and we're investigating the fingerprint of individual fatty acid methyl esters in the fuel as a means of indicating whether sustainable biofuels have been adulterated. But our capabilities go way beyond fuel testing, as we continually develop a whole new range of comprehensive advisory projects, digital services, and software available on a single unified platform to further support our customers in their efforts to reduce emissions. We call it data-driven decarbonisation. MIRES is just one example of this, a unique and powerful digital management system which gives operators an overview of both the emissions performance of each vessel within a fleet and even the whole fleet in real time. And complementing this is MSIS, Advanced In-Stack Monitoring, which, like all VPS systems, complies with maritime regulation, allowing operators to measure their total mass emissions inventory and manage their ESG reporting. We're market leaders in these services, and sustainability is at the heart of our business and culture. We're making a difference by helping our customers to optimize their use of resources, minimize their emissions, keep their people safe, and operate more sustainably. And we're committed to doing this long into the future.